Alright, what's up guys? It's Dafro Gaming here, aka Wormrida on Steam, and today we're going to be going over the first part of our open world RPG tutorial series. So now we're actually going to be writing some code. If you haven't seen the setup video, I'd highly recommend going over that. That is if you want to make your own game and just follow these steps. Go ahead and set up your sprites the exact same way I do. I'd recommend having the same number of sprite frames in the same places. And you can just import your own sprites. Otherwise, if you're going to be following along exactly and making this project with me, then you'll find a download to these sprites that I'm using in the description, and we can just go ahead and get started. So first thing we're going to do is set up the board. So if you see here, I have 6 screens on this board, and I'm just going to make a pretty good sized generic looking board. You can go ahead and take some time, make yours look pretty if you want, but just for the tutorial, I'm going to go ahead and just slap something together. Alright, there we go. That's a real basic board. We have 3 big screens up top, 3 big screens down below. I'd recommend using the same screen setup if you want to follow along, just because the size of your textures and the location of textures will be highly dependent on the screen size. If you want to do the math on your own to get things lined up for your custom screen size, feel free. And I just want to make an announcement really quick. The RetroGadgets modding team has recently come out with a mod that allows you to code in Visual Studio's code rather than the editor here on the side, which is super helpful. It's a little bit buggy, but once that becomes stable, I'll do a showcase on that just to show it off, because it's going to be so much better to code in an actual IDE versus, this little side screen. But anyways, all we have is a D-pad and 2 buttons. Now going over which chips we're going to need. We are going to need the keyboard chip that's here with the K, because we're going to map our keyboard inputs. We're just going to need the basic video chip. The smallest CPU will work. If you want to use event handlers for your key actions, you could choose a larger CPU. We'll put an audio chip on there, although I don't have any plans for audio at the moment. We will need some memory, and we will also need ROM. And I think that's it. Okay, so now let's go ahead and set up our first script. So instead of CPU.lua, this is going to be our game controller, is what we'll call it. And in this tutorial, our whole goal is to do the player controller. Get the player controller animations going, and get those all working properly. So for the game controller, if you refer to that graphic I showed in the last video, this is kind of going to be our managing script. It's going to call all the other scripts, and so we want to make sure this is the one that the CPU has the source for. Good. So, oops. Now let's go back and go ahead and create a new script. We are going to make our player controller. Whoops. Confirm, and then also since we will be doing the animations, I'm just going to import everything right now. In this video, we're only going to be using the attack animation and our walking animations. Okay, there we go. We got everything imported. We're going to be using the walking animation and the attack animation for our player controller, and now we can jump into the code. So if you've never done object-oriented programming in Lua, it's going to look a little bit different than we're used to. We're not going to use this default update function nor the default setup, because the CPU is not actually going to be running this code. This code is going to be like an object file that our other script will call and create. So a few things we'll need for the animations. We're going to need the ROM, and then what else? We are going to need the D-pad. We're going to call it attack button. This is going to be one of our input buttons there on the right hand side of the device. We'll just say this is LED button 1, which is the lower one, and then we're going to set up an interact button for our interaction that'll be used to enter buildings. I'm just going to have that be the higher button here. And then we'll need the video chip. And, you know, I should probably specify the type on these. This is an LED button. This is also an LED button. This is a D-pad. And, whoops. This is a ROM. Okay. Now we have the video chip in. And then last thing we're going to do is import both of our animations. We're just going to call it walking. It's a sprite sheet. And we'll load that from our ROM. User.sprite sheets. And then I have called it walking animation. And we'll just go ahead and copy this. This will be attacking. And this is just called attack animation. Okay, so there are a few more variables we're going to need. I am still going to be using TPS-based animations. If you guys don't know what the TPS is, when you run the game, the TPS is kind of like the ticks per second. It's like the frames per second. I will be using that for animation, although I will mention right now there is possibly a better way to do animations that is not dependent on the performance of the CPU or actually your computer. So if you're not running at 60 frames per second, this could theoretically impact your performance. Okay, I'm going to go ahead and recommend this page right here. This is the fan-made RetroGadget docs. I'll have a link to it below, kramachu.github.io, and they actually have some code resources here under the CPU. It goes into a lot more depth into the docs than the standard development docs do. I'd highly recommend using this, and you know, you can even get some code on how the event channels work, how to set up events for buttons. We won't be using that just because I've kind of set this up old-fashioned, just based on button up and button down. But this could actually theoretically increase performance in the case that this project gets so big that we actually need to optimize things. Eventually I might factor in these events. And then also, if you look here, creating consistent interpolation. So they propose that instead of using a number plus 1 in the update function, which is based on your ticks per second, you can use your number plus 1 times the CPU delta time. This won't work for the way I've set up this project. I might do a better animations tutorial another time, but just for the basics, we are going to be using this since I think if you're running RetroGadgets, you're probably going to be running at the maximum TPS of about 60, although this could be an alternative if you want to use that. So since we're going to be using TPS-based animations, we are going to have an animation ticker. In fact, we're going to be using 2 animation tickers. The first one is going to be for walking, and then the second one, actually we'll call this attack animation. The second one's going to be used for our attack. And then we are going to have a variable called facing. This is going to be a vector 2, and we'll just initialize it to 0, 0. But there we go. That should be good. And then I did make a note here just so we know. Left is going to be the vector 3, 0. Right is going to be the vector 3, 1. Up is going to be the vector 7, 1. And down is going to be the vector 7, 0. And so what this is referring to is the idle animation of this on the sprite sheet. So our left idle animation is at position. It's column 3, row 0, and then over here, right is going to be column 3, row 1. Remember, those are, right is going to be below the left walking animation on that sprite sheet. In fact, I'll just pull it up right now. Right, so this is what it's going to refer to, is which sprite here that our idle animation is. So this would be 30, 31, 70, 71. And then speaking of which, we forgot to initialize our sprite sheets. I decided to go with 32 by 32 sprites. I thought this was a pretty decent size. Remember, your sprite sheet has to be a power of 2, so keep that in mind. And then our house sprite, I'm just going to go ahead and do these all. These are 64 by 64 sprites, just so we don't run into issues later. And then grass, this is also a 64 by 64 sprite. Same with the shrubs. And the attack animation, 32 by 32 as well. There we go. Yep, that looks good. Oh, looks like we might want to clear this one up a little bit. There is just a little spot there. Just going to press delete on the keyboard. Sometimes those semi-transparent pixels don't really show up in photo editors, and they become a lot more noticeable once you import the sprite. Let's see, all these look good. Yep, don't really see any transparent pixels on the side. Okay, so I think that's good. Let's get back into the player controller. So for object-based or object-oriented programming, we're going to be setting this up kind of like a class. So classes in Lua are kind of, they're depicted as structures, or as like our dictionary. So to set up a class, we're going to call it local player controller, and then we'll just set that to blank. And then what we're going to do is we're going to have a function here called player controller.new. This is what we're going to be calling to set up, to create a new instance of this object. Okay, and then what we're going to do is we're going to keep this pretty similar in every class that we do. This is going to be local instance. This is going to be the instance of the object that we're returning. So this is where we're going to define our local variables for each object. So these will be different on each object that we create if we want them to be. So you could think of this up here, our player controller.new, as our constructor, and then we're going to be returning this instance object as our player controller. So we will return inst at the bottom here, and we will keep that down towards the bottom. So for our local variables, we're going to have a few of them. We're going to call one scroll x. This is going to affect our player's position in the virtual world, because we're not really moving the player. The player actually, the player sprite stays in the middle of the screen, and then scroll X and Y will dictate where they are on the grid. So we're just going to say player speed equals 1. You could change this if you want them to move faster. Is attacking equals false. Oh, looks like I forgot commas here. Is interacting. We'll initialize that to false. And then is inside equals false. And that's going to be used to determine if they're inside a building. So the first function that we're going to create here is going to be our update function. You could think of this as like the update function in a regular script, except this has to be called each tick versus being called automatically. Now, if we want this function to be viewed by other scripts, we will create it inside our player controller.new class. If we don't want it to be viewed by other scripts, we could have a helper function down here, outside of our class, in which case the class can call this function, but this function will not be viewed by other scripts when they are looking at our player object. But that being said, we want the update function to be called by the main game tick, so we will create it here. And then the way we do this is we are going to say instance, semicolon, update player, end. So this is how we're going to set up the function. And what this allows us to do in our other class is say, okay, player controller, semicolon, update player, and it will refer to this section right here. You need to have instance, colon, update player. We'll use the colon for functions and methods, and then when we refer to these local variables, these will be instance.scrollx, instance.scrollY. And keep in mind, other scripts will not be able to see our animation ticker or any of these global variables. Okay, so we are going to start off with the animation ticker reset. The way I set this up is that each animation cycle takes 20 ticks. So if animation ticker is greater than or equal to 20, then animation ticker is equal to 0. End. And notice I did not use instance.animationTicker because this is a global variable. Then under here, we're going to set up our check if interacting. So if our interact button dot button down, then instance dot is interacting is equal to true. And then else if interact button dot button up, then instance dot is interacting will be set to false. And this will just help so that way other scripts can figure out if our player is interacting or not, because they won't other scripts won't necessarily be looking at the D-pad or our interaction button or our attack button. So we want to localize that here. At least that's the idea. Next up, we're going to check if the player is attacking. So if attack button dot button down, and I like to be clear on the else if statement to say specifically that if the attack button up state is equal to true, theoretically you could probably just use an else, right? Because if the button's not down, then it's going to be up. And actually, we don't need to say if it equals true because this statement itself will just default to true or false. Okay, so if the button up is true, then instance dot is attacking equals false. Next up, we are going to check if the player is moving. Scroll down, give ourselves some space. So if instance dot is attacking is equal to true, then we want to attack in the direction that they were last facing. So we're going to do that with our facing variable, that vector up there. Keep in mind, since we are initializing this to 0, this won't actually work. Actually, I might have to just initialize this to another value. We'll come back to that in a sec. But essentially what this is going to do is use the attack animation in the direction that the player is facing currently. So we are going to call a new function called attack. In fact, maybe we should just set that up now. We are going to set up our attack function outside of the instance because we don't want other scripts to be calling attack. We only want the player to be able to call those. So function attack. And then we're going to have a variable called direction, which is going to be a vector2. We are also going to have a function called walk, and it is also going to take direction, which is a vec2. So if attacking is true, then we are going to call attack, and we are going to pass in our facing variable. Else if, now this is where the majority of the movement comes in. If our pad.x is equal to 0 and pad.y is equal to 0, then we are going to reset the animation ticker because the player's not moving, and we just want them to be on the idle animation. And then we're also going to call an idle function, which I forgot to create, and we're going to pass our facing vector into there. Going to go ahead and set up idle down here. And idle will also use this variable. Okay, so we pass facing into idle. So otherwise, if they're not idle, then they're most likely pressing on the D-pad, right? So we'll say if pad x is greater than 0, then, oh, what happened there? We'll say our instance dot scroll x equals instance dot scroll x minus player speed. Instance dot player speed. Else if pad dot x is less than 0, then instance dot scroll x equals instance dot scroll x plus instance dot player speed. And I'm doing all of these in else ifs because these are exclusive conditions. I only want them to be attacking, idling, or moving to the left, moving to the right. I don't want them to be doing two of these actions at once. So that's why we're using so many else ifs here. So not sure why it tabbed me down there. Else if pad.y is greater than 0, then we are going to set our facing vector. In fact, I forgot to set the facing vector here. So if pad.x is greater than 0, we will move them by the scroll speed, and then we are going to set our facing equals a new vec2, and we will have it be 3, 1. So if we look up here, 3, 1 is going to be right. So that's where I'm getting that number from. It'll probably make sense in a second once you can actually visualize this. And then we're going to call our walk function with our facing variable. Now this is going to be left. So if we scroll up here to the top, left is a vector of 3, 0. So facing equals vec2 of 3, 0. And then we'll say walk of facing. Okay, so if pad y is greater than 0, pretty sure this is going to be moving up. We'll say facing is equal to vec2, which is 7, 1. We'll set the scroll y this time. Oh, it keeps defaulting to scroll x. Plus instance dot player speed. And we'll call walk with facing. And last but not least, if pad y is less than 0, then we will go ahead and say facing equals vec2, this should be 7, 0 this time. Instance.scrollY equals instance.scrollY minus our player speed. And we'll say walk with facing. And put the end right there. And then let's see here. We need to use our animation ticker. Since this is our update function, we'll update our animation ticker here. We reset it to 0 if it's greater than 20, but we also just need to increment it by 1 every tick in the program. So we'll say animation ticker equals animation ticker plus 1. And return instance. All right, so the meat of our class is pretty much done right here. Now we need to fill out our walk, attack, and idle. So we'll start with our attack function here first. And remember, each attack function is, we're going to be using the animation ticker in sets of 20 frames. So our attack function is going to take 20 frames and then reset back to its first frame. So since there's 4 frames, each one's going to be 5 frames, or 5 ticks per each frame on the sprite sheet, if that makes sense. So we'll say if our attack animation ticker is greater than or equal to 0, and our attack animation ticker is less than or equal to 5, then we'll say is attacking is set to true. Is attacking equals true. And then we are going to draw our sprite. Where is it? Draw sprite. We're going to draw it in the center of the screen here. So all of our animations will basically be drawn right in the center of the screen. We'll try and keep it consistent. And I've already done the math for this. So you could look at, the screen width divided by 2, screen height divided by 2, and then usually you have to subtract 16, since that's half of our sprite width and height, since our sprite is 32 by 32. So for us, that is going to be 80, 48. We're going to use our attacking variable there. Direction.x is going to be used for the sprite sheet. So our direction is this variable's a vec2. We're basically just packaging 2 integers together with this vector, and then we're using it to specify the sprite sheet x and the sprite sheet y. So then direction.y, color.white, color.clear. And let's just go ahead and tab that down to the next line so it doesn't get too long there. All right, so that will set us up for the first 5 ticks of our attack animation. Remember, this attacking variable here refers to our sprite sheet that we declared at the top. So now we'll do the next 5 ticks of our attack animation. So if attack, oh, it's because there's 2 parentheses. We'll say if it's greater than or equal to 5 and attack animation ticker is less than 10, then we are going to do the exact same thing. We're going to draw the sprite there, except we are going to use our attack animation direction.x minus 1. Whoops. Because our idle animation is the furthest sprite to the right, we're going to subtract 1 for each sprite in that sprite sheet. So 5 to 10 will be -1, 10 to 15 will be -2 in the X direction on that sprite sheet. And so it'll be easier if we can just copy this, go ahead and paste it. So now if it's less than or equal to 10, or greater than or equal to 10, and less than 15, then we're going to do the same thing, but direction 2. And then on this one, we're going to do 15 to 20. And then this would be direction.x -3. And then we have to put our end right there. All right, function walk is up next. We're going to do walk very, very similarly. In fact, we could probably just paste in that code that we just used. We're going to use an if statement here. So if attack, instead of attack animation, we're going to use our animation ticker variable instead, since that is for walking. So we'll do if it's greater than or equal to 0 and it's less than 5 for the first one. Then we are going to draw the sprite, but this time instead of our attacking animation, it's going to be our walking sprite sheet. And we will keep direction.x, since the first one is our idle, kind of our default walk animation. It's the first sprite in the sprite sheet. So next up we'll do an else if. In fact, yeah, we copied that. So now we'll do 5 to 10, direction x -1. This will be 10 to 15. And this will be our 15 to 20. So that's -1. This will be -2. And this right here will be -3. And notice the direction.y won't be changing. As long as we're walking in the same direction, then our little movement controller right here, it will be always be passing the same vector of 7. Or excuse me, 7, 1. It'll be passing the same direction each time. And then we'll just be subtracting by 1, depending on where it is at in the animation. So, whoops, did not mean to take a screenshot there. We'll go ahead and end that. And I think the last one here is idle. And our idle animation is going to be the easiest, because all we have to do is draw our default idle sprite, which is just the direction.x and direction.y. So this is also going to be at vector 2 of 80, 48, right, the middle of the screen. Our idle animation is just part of the walking one, and then we'll do direction.x, direction.y, color.white, color.clear. All right. Did I spell everything correctly? I hope so. We might have to come back and double check. Let's see here. And then I am actually forgetting one thing. We actually have to return our player controller class. Oh, man, I hate this editor sometimes. So this player controller that we create up here, it's going to create a new instance. And our instance is what has these functions on them. So anything labeled instance : is a function that we can call from outside of this object. These other functions will only be seen from our instance in the object. And then one thing we have to do is return the entire object itself. So we have to return our player controller, so that way it is completely wrapped here. And that is this variable right here that we're returning. So basically, what it's doing is it's creating this variable with these methods and these other subvariables, and then it's assigning it to this dictionary type, in which case it returns this. So now what we're going to do is we're going to import our new class right here into our main file, which is the game controller, and we're going to test it out and see if we can get it working. So to import a class in Lua, what we're going to do is go local player controller, and we're going to use capitals because that is usually the standard type definition for classes, equals require, and it is our player controller dot Lua. Now we are going to set up a function here called setup player, just so that way we can break this down. And what we're going to do here is we are going to say we have a player object. We'll just call it local player. We won't define the type at the moment. And then we'll just say player is equal to player controller dot new. Right? So it'll be calling that function in our class. And then what we can do in the update is just say player update player. And see how it has autocomplete? That means we set it up correctly. And we're using the semicolon to define that this is a method or a function in that other class. So let's see here. Are we missing a power switch? Oh my goodness. All right, and we got an error. Let's check out what this is about. Attempted to index nil with update player. Ah, yes. So we actually forgot to call setup player, so therefore the player object here is just considered nil. So setup player, we have to call this before our update function happens, and we should now get some screen drawing, but it doesn't seem like we are. I also wanted to mention I did find something else. We forgot to update our attack animation in the player controller. Yes, right here in our attack function, we forgot to put attack animation ticker equals the animation ticker plus 1. So you should go ahead and add that. You might have caught it, although I did not. All right, so one other thing I forgot to do during setup, after we did the video chip, we actually have to select the correct video chip for all of the screens. This will allow RetroGadgets to view all of our screens as one coherent screen, or one continuous screen, not coherent. Okay, and then we haven't set up our keyboard mapping yet, but we will do that in just a second. Okay, so now when we run the game, we get an idle animation if we stop moving. We can look up, look to the left, look to the right, and then I think the lower one should be attack. Yep, and the attack animation. Uh-oh. All right, it looks like I actually completely forgot to reset the attack animation ticker back to 0 when it gets to a certain point. So if we look at attack, this animation, after we viewed that sprite sheet, it's only 2 separate frames for the attack animation, and then we'll use our idle animation for a third one. So we're actually not going to be counting to 20 here for this animation, since it's only a 3-frame sprite. And what we're going to do is we are going to set our attack animation ticker back to 0 if it gets to 14. Right? Because 14 would be the end of this animation. It will play this last frame up until 14, and then once it reaches 15, it will no longer play that. So then we'll say attack animation ticker equals 0, and attacking is equal to false. All right, and then we are incrementing our attack animation ticker there. Oh, We got a runtime exception. Yes. Looks like we forgot the end here. Oh, actually, no. We are going to have this be part of this else if statement. So, therefore, it's only going to check if the animation ticker equals 14 under the condition that it's already between 10 and 15. Okay. So now we get our attack animation, and looks like there's still one little artifact there. It shouldn't be flashing quite like that. Let's see, did I forget the bounds here on our animation? We start at 0, 5. Ah, yes, this should not be less than or equal to 5. Ah, yeah. Okay, I just realized our attack animation, since it's only 2 frames, we don't have a -2 here. So what we're going to do is we're going to play the first frame when the sword's just barely out, then when the sword's all the way out, and then we're going to go back to where the sword's just barely out. So I think that should look a little bit better as a loop. There we go. And see, now we're not getting that glitch there where it doesn't know where we're looking. It does still occur if we just attack, because our facing value here is not initialized to the left, which we should probably go ahead and do that really quick. Right, so the left is 3, 0. And now we get rid of that glitch where if they're not facing any direction and they attack, it should work. All right, I think that's looking pretty good now. We have the basics done. I think in the next video, we're going to go over the background and dealing with the scenery, the background textures, moving that all around. If you guys enjoyed this video, I'd greatly appreciate it if you left a comment. Let me know if there's something you think I should add to this series, or if you think there's something I'm missing. The one thing to note is that this attack method here of just having is attack equal to true anytime the button's held, this isn't really going to be great for an actual attack system, considering like if we just check that value, it's just always going to be true. So like the DPS would be pretty insane. It's not like it's really registering just if they click the button. It's just when it's held down. So we'll probably update that if we end up doing an actual attack system with enemies. But this is just a basic system for the animations. And I think that is all I wanted to cover in this video. So check out the next one. It'll be released in a few days. And yeah, thanks.